Hello, today we're going to talk about vector equation of a line. The vector equation of a line is an equation that identifies the position vector of every point on the line, which is kind of difficult to really understand what it's talking about because it's a very mathy definition. So let's draw a picture of what's happening. But before we even do that, we are finding the equation of a line. So if you think back to algebra for a minute, the equation of a line is y equals mx plus b. Well, now we want to think about this equation of a line in terms of a vector instead of just a normal line. So we're going to try to apply the same concept. So let's say that we have point B. Okay, point B is somewhere in the universe. Point B, I realize that this is a B. It's not necessarily a y-intercept, but you could think about it as like your starting point. So point B, we don't really want to think of it as just a point. We want to think about it as a vector. So we need a direction to go. Every single point can be written as a vector if we draw the vector from the origin. So vector B, or point B, it would be the terminal point of our vector from the origin going to point B. Let's just call this vector B. Again, this B does not necessarily mean y-intercept, but you can think of it as like your starting point. Okay, so when you're thinking about a line, the next thing you would do would be to figure out your m, your slope. How you have your B, where you start, and then how do you move to get to your next point, right? So let's just pick an arbitrary next point. How about, we'll call this point C. So we want to get from B to C. And again, when you're back in algebra, you really just, you connect these two dots to find your M. Your M is telling you what direction you go. So when you're doing this and you're doing your vector equation of a line, the vector that would connect B to C is your slope. We can call this our M vector if you would like. Now, remember that there could be a lot of different versions of M. M is just telling you your direction. It's telling you how you're getting from B to C. Now remember, there are lots of vectors that could be in the same direction as M. They would be parallel. So in this vector equation of a line situation, you actually have a lot of different potential correct answers. So just keep that in mind as we continue working. So if I have my vector B, starting at my vector B, and then I follow the path of M to get to C, my final vector C would be where I'm ending. And we'll call that just vector C, the position vector of vector C. Now, any version of M will get me any other point on this line. So if I were to make M a little bit bigger, maybe by using a scalar, I could end up down here. Or I could make it smaller, and I could end up right here, or I could even make it negative and I could end up back behind B, okay? But the point is that every single point on this line represents a vector from the origin. So this looks in general, we have vector B plus vector M has to equal vector C. Now, again, vector C is one specific point, but I want to be able to manipulate M and change M to give me any point on the line. So M, just like in y equals mx plus b, is going to have your variable. This time, I'm going to call it t, just because a lot of times we turn these vectors into parametric equations, and t is always handy to have in a parametric. So this is actually how you do this. You find your starting point or your starting vector. You find your slope. Or you find your vector between your 2 points. And then that's giving you your resulting vector. I called it C here. Sometimes we just call it R for result. You'll see that kind of used interchangeably, but the letter doesn't matter. So let's do a couple examples. Determine the vector equation of a line through the points 3, 7, and 1, 2. And you heard me say, and I'll say it again, that there are several different answers that you could actually come up with that would be correct for these types of problems. So the way that I do it or the way that your friend might do it could be different than you, but you can both be equally correct. So you have to first establish a starting point. Either one of these points expresses a vector, could be a starting point. It doesn't really matter which one you pick. Since 3, 7 is listed first, I'll just use 3, 7. So 3, 7 is how I'm starting. The vector between these two, I have to calculate just by doing some basic math. You're going from 3 to 1, so that's -2, and then 7 to -2, so that's down 9. A vector parallel to this would be 2, 9, and that would give you essentially the same answer. Your line would just appear to be going in a different direction, but we'll stick with the -2, -9. So now we really have all the information we need to write our vector equation of the line. So you have your initial point at 3, 7, plus your vector between your 2 points, which represents your slope. And this needs your variable on it, t. And this would equal your resulting vector. Now, there's a couple different ways you can express this. This way is called vector form. You can do some simplifying and turn it into component form, which would be just kind of combining your like terms. 3 plus -2t or -2t. And then 7 plus -9t, or just 7 minus 9t. This would be like your component form. Still represents an equation because you have variables here. And then you can also turn this into a parametric equation. This would be your x. X equals 3 minus 2t, and y equals 7 minus 9t. All three of these ways are equivalent and correct ways to express this vector equation of a line. Let's do another one, thinking about it in a different way. Write the equation of y equals -3/5 x plus 5 as a vector equation. And again, there are going to be multiple correct answers to this. The easiest way to do it is just to pick 2 points on the line. So if I have my equation, I need to find 2 points on this line. One point that's really easy to find would be the y-intercept, because you can just plug in 0. So 1 point is the point 0, 5. You can come up with any point that you want, but again, it's nice to have numbers that are round, whole numbers. So if I use 3 as my x, I'll get -5 plus 5, so I'll get 0. So another point that I'm going to use is the point 3, 0. That's nice that it uses the x and y intercept. Then you just repeat the process that we did before. So pick an initial point. It doesn't really matter which one is your initial point. I'll pick 3, 0. So I'm going to express that as a vector. Again, this would just be the position vector from the origin. Plus, and now I need to find my slope. So my vector between these 2 points, if I start at 0 and go to 3, I'm going up 3. If I start at 5 and go to 0, I'm going down 5. And actually, I'll stay consistent. And I will make this be my initial point of my vector. So I'll go 3 to 0, so that's negative 3. And then 0 to 5, that's positive 5. You do want to stay consistent when you're doing your vectors. So if you decided that this is your initial point or your starting point, then you want to make that be the initial point in the vector as well. It's going to make the math be a lot simpler. So this could be your equation. Your resulting vector would be this. Or you could express it as 3 minus 3t, 3 minus 3t, and then 0 plus 5, which would just be 5t. And again, there are lots of versions of this. If you would have said 0, 5 is your initial point, then you would have had a couple different answers. The next one, you can also do these in 3 dimensions. Technically, this would be a plane instead of a line, but still quite interesting to work with. So determine the equation of line defined by these 2 points. And then find the position vector r halfway between these 2 points. So now we're doing some actual calculations here. So we have, I'll make P be my initial point. So this is 6, 7, 5 plus, now let's look here and here. So to get from 6 to 3, I have to go down 3. To get from 7 to 2, I have to go down 5. And then to get from 5 to 11, I go up 6. So I have that vector equation of the line. And I typically like to write it in component form, just because I feel like it looks a little cleaner. I think it's more of a personal preference thing. So 7 minus 5t, and then 5 plus 6t. Okay? So that's my equation. I want the position vector, or I want the vector, the r, the resulting vector, that's halfway between these 2 points. So if you want to go halfway between P and Q, you would simply just set your T to be half. So this is 6 minus 3 times a half, 7 minus 5 times a half, and then 5 plus 6. Times a half. And this would be the position vector that is halfway between these 2 points on this line. So we have 6 minus 1.5, which would be 4.5. We have 7 minus 2.5, which would be 4.5 again. And then I have 5 plus 3, which is 8. And this would be my resulting vector. That would be halfway between 6, 7, 5, and 3, 2, 11. And it's okay that this isn't exactly in the middle of some of these points. It's totally fine. Because remember, you're following this based on the slope of the line, not necessarily the most efficient way of getting from the 2 points, which would be the true midpoint. This is all I have for you today. Go ahead and work on your practice problems.